Hello everybody. Today I'll be giving a presentation on minutiae-based fingerprint recognition system. This project is a part of my coursework Pattern Recognition at the University of Florida under the guidance of Professor Dapeng. I will try to keep the presentation simple and understandable in layman's terms. So the agenda for today. I will start with an introduction followed by stages of the fingerprint recognition system, brief description of each stage of the system, understanding the importance of each stage, conclusion and future work, and finally I'll end with a MATLAB demo. So, fingerprint recognition and introduction. Fingerprint recognition is a kind of biometric identification. Before discussing about biometric identification, let's understand the traditional and simpler form of identification, which may be in the form of ID card, password, etc. Though they are simple, there are certain issues associated with them. For example, an iCard may be stolen, or a password can be hacked. Biometric identification and authentication, though complex because it involves pattern recognition and signal processing algorithms, then the traditional methods of identification is gaining popularity because of its ability to uniquely identify a person and give him access to a secure system. Examples of such secure systems can be laptops, mobile phone, building, or restricted area in a college or office campus, etc. It is also used in application systems like fingerprint attendance system, loyalty card system, alternatives, criminal investigations, etc. Biometric identification is an identification methodology which is actually based on the matrix of human characteristic, and fingerprint recognition is one of the most popular form of biometric identification. Human fingerprint consists of some detailed patterns named as minutiae, and these patterns vary from person to person, and so it can be used to identify an individual. In this presentation, the entire process of fingerprint recognition involving pre-processing stage, minutiae extraction stage, and minutiae matching will be studied. So, biometric identification can be of two types based on the features. One is the physiological identification method, and one is a behavioral based identification method. Fingerprint matching is a kind of physiological based identification. There are other kinds like face, hand, eyes, all fall under the physiological identification method. Voice, signature, keystroke, dynamic fall under the behavioral identification method. So this is an overview of a fingerprint recognition system. So the data acquisition system can be either a sensor, a scanner, a camera, a picture, or a fingerprint, etc. So this input fingerprint is then fed to the signal processing unit for pattern extraction, and in this case it is the minutiae extraction. Then the stored reference template is fetched from the database, and then in the decision making unit the two templates are compared and checked for a match. If the input template is matches the reference template, then that it means it is of the same individual and the person is given access right, or else it is not a match and the person is denied an access or whatever is application. Now, the fingertips have detailed or distinct patterns of ridges and valleys. The identification of these patterns help in fingerprint recognition as it varies across individuals. Study of the ridge flow pattern shows that certain anomalies, which are termed as minutiae points, exist. These points consist of mainly ridge bifurcation point, where the ridge divides into multiple branches, or the abrupt endings or terminations. The other kinds of minutiae points are independent ridge, ridge dot or island, lake, spur, and crossover. The various kind of minutiae patterns are shown in this figure. But in this project, we are mainly concerned with the ridge ending and the ridge bifurcation points. So this diagram shows the stages of the minutiae-based fingerprint recognition system. The fingerprint recognition system can be used either independently or as a part of a larger system, and this entire fingerprint recognition system can be broadly categorized into three stages: the fingerprint input stage or acquisition stage, the minutiae extraction stage, and the minutiae matching stage. So now the fingerprint input or acquisition stage. The fingerprint acquisition is done by some optical or semiconductor sensors, scan images, camera images, etc. To make the detection system more robust in this project, scan fingerprint using paper and ink technique are used as they are more prone to noise, and testing with such distorted and noise-prone inputs would help to make the algorithm for the design of the fingerprint detection more accurate and optimal. Because so while testing, if we are testing with more noisy inputs, then definitely if and we are able to, our algorithms are designed in such a way that they can handle such noisy inputs, then definitely in real-time scenarios when the inputs will be noisy, the detection algorithm will do a good job. Next stage is the minutiae extraction stage. So the input from the sensor or the picture or the fingerprint the picture of the fingerprint is then fed to the minutiae extraction stage. So this is one of the most crucial stage of fingerprint detection system. It involves identification of minutiae points, ridge bifurcation, and ridge endings. Some pre-processing and post-processing algorithms to remove noise and spikes for generating better template for minutiae matching are developed. This stage improves the quality of the image by increasing the contrast between the ridges and the valleys and by fixing the false or broken ridges. So in the pre-processing stage, first we work on the image enhancement. So this is done through histogram equalization. Histogram equalization enhances the quality of the image by increasing the contrast between the image. So the left side of the image is the loaded fingerprint or the fingerprint image without any pre-processing, and then the right side is the output of histogram equalization, and it clearly shows that there is that it has enhanced the image by increasing the contrast in the image. So the next step of image enhancement is by using fast Fourier transform. This helps to fix the falsely connected ridges and the broken points of the ridges that falsely shows up. The image is divided into some 32 cross 32 blocks, and then on the 32 cross 32 block we apply for Fourier transform. So FFT for the block is multiplied by its magnitude. This enhances the specific block by its dominant frequency. The equation for the enhanced block is as shown here, Gxy. The value of k needs to be properly chosen, as if it is too high it could lead to false reach connections, which of course we don't want. So in this project we have experimentally found out that k equal to 0.45 gave proper results. Next step of the pre-processing stage is the image binarization. The main motive of image binarization is to have two colors, black and white. The regions or patterns are marked as 0 and the background is marked as 1. The pixel with label 0 are assigned white color and the pixel with label 1 are assigned black color. Image binarization is done to make the ridge patterns more prominent. The image is divided into 16 cross 16 blocks and the mean intensity is calculated for the block. If the intensity value of the pixel is greater than the mean value, then it is assigned label 1, else label 0. Now, based on the labels, they are assigned colors, black and white. Next is the image segmentation. So mainly in this stage, we are more concerned in fetching the region of interest of basically in this stage, what we do is we separate the fingerprint from the background. So region of interest is the area of image which contains useful information or pattern which would help in recognition of the pattern. In this algorithm, the ROI is determined by a two-step process: block direction estimation and the morphological operation. Block direction estimation. For block direction estimation, the gradient of x and y direction are calculated by using two Sobel filters for each of the pixels of block size 16 cross 16. For each block, the block direction is calculated by using the least square approximation using the following minutiae formula: 10 to beta equal to as shown here. Next, the blocks which do not contain crucial reach information are discarded by the formula mentioned below. So if certainty level, that is represented by E, is less than threshold, then discard that block. Morphological operation. This is based on two morphological operations, open and close. The open operation helps in removing the peaks in the signal caused by noise, and the close operation helps in removing the cavities in the image. So the open operation expands the image, whereas the close operation shrinks the image. So here is the left side is the block direction estimation of the ridges, and in the right side is shows we have actually separated the region of interest from the background. Next is the minutiae extraction stage. This is one of the important stage of the fingerprint matching. Here the minutiae of the fingerprint is extracted. It is executed in two stages: reach thinning and minutiae marking. So the figure in the right side, the reach thin image on the right. So the binarized image is fed to this stage, and what the reach thinning does is clear. We can clearly see. So all the thick ridges have been replaced by some thin lines. There is also another figure which shows the output after edge break removal. So how the ridge thinning is done? So iterative application of ridge thinning algorithm to the segmented fingerprint input to remove the redundancy in the ridges. It takes 3x3 blocks for computation and then ensures that the ridges are 1 pixel wide. The redundant pixels are iteratively searched for through several scans and then marked by this algorithm. Morphological operations are applied on the thin ridges to remove the spikes and edge blocks. Next stage is the minutiae marking. So the crossing number technique is used for minutiae marking of the ridge thinning phase. This is based on the pixel placed at the center of a 3x3 block and then searching for the neighboring pixels marked as label 1. If the centered pixel of a 3x3 block is 1 and then it has 3 neighboring pixels marked 1 as shown in figure 12.1, then it is a case of ridge bifurcation. Next, if the center of a 3x3 pixel is 1 and it has only one neighboring pixel marked as 1, then it is a case of ridge termination, as shown in figure 12.2. Next is the figure 12.3. So here, if the uppermost and the rightmost pixels are marked as 1 to the central pixel, then the branches outside the 3x3 blocks are examined and duplicated branches are eliminated. The inter-ridge distance d, or the distance between two ridges d, is then calculated and the minutiae are marked. So this is the output of minutiae marking. So here we can see there are some colorful points. These are the minutiae points. Next stage is the post-processing stage. So the false minutiae break due to lack of ink or the inappropriate ridge connection due to over ink is not fully removed by the pre-processing module of the fingerprint recognition system. The preceding modules of the fingerprint recognition system could also generate some false minutiae or artifacts. For accurate fingerprint detection, a post-processing module is highly recommended after the extraction of the minutiae. So basically, in the post-processing, we do a we check for 4 conditions. So here in the right side, we can see there are 7 cases of false minutiae points. So here we'll discuss about all of these cases. So case M. So first is case M1. If the 2 minutiae fall on the same ridge and the distance between one bifurcation and termination is less than the inter-ridge distance d, then remove both the minutiae. This can help in solving the problem of false minutiae. Case M2 and M3. If 2 bifurcations are on the same ridge and the distance between them is less than d, then remove both. Case M4, M5 and M6. If the 2 terminations are less than distance d and if there are no other terminating points in between these 2 terminations, then these are false minutiae resulting from false ridge breaks and needs to be removed. Case M7. If in a short ridge there are 2 terminations which are located at a distance less than d, then remove both the points. So here is a post-processing stage output. So the right side image is the image after we have removed the false minutiae, and we can see that the number of points, the number of minutiae here are comparatively lesser than the left one, in which we had gone in the previous, which is the output of the previous stage, and it has false minutiae. So after the post processing stage, those false minutiae points are removed, and we have the proper minutiae points. Next stage is the minutiae matching stage. So this is the last stage of the fingerprint detection system. In this stage, 2 fingerprints inputs are fed and then they are checked for similarity. It has 2 sub-stages, the alignment stage and the match stage. Minutiae matching and the alignment stage. In this stage, a minutiae point is chosen for 2 fingerprints provided. The similarity between the ridges is calculated for the 2 minutiae points, and if it is greater than a threshold, the translation and rotational adjustment of the coordinate axis is done to match with the reference minutiae axis. The similarity between the ridges of minutiae from the 2 fingerprints are calculated using the equation mentioned below. S equal to summation of xi by xi square by xi squared to the power half. The score for the similarity is computed, and if it is greater than 0.8, then the angle of rotation is calculated and the axes are translated and rotated to match the reference axis. If the similarity score is less than 0.8, then the next pair of ridges are matched for similarity. In the figure here shown, to match the coordinate axis with the reference and a rotation of angle alpha is done. Minutiae matching and the match stage. So after the minutiae alignment, wherein the coordinate axes of both the images are aligned, the patterns across each minutiae of the 2 fingerprints are matched for similarity. For better accuracy and precision of the minutiae matching, a rectangular box is placed across each minutiae point, and if the minutiae that is matched is placed within the box or have less direction difference, then they are regarded as matched pairs. The percentage of total number of matched pairs to the total minutiae count is then calculated. If the percentage calculated in this stage is greater than 80%, then it is a case of fingerprint match. Test results and summary. So in this stage, we have actually tested our system with some 85 inputs, And then also we have tested by removing various stages of the minutiae of the fingerprint detection system to understand the importance of each stage. So here are the results. It was observed that the pre-processing of the image is a vital step in the process, without which the accuracy of the algorithm drops down substantially. The image binarization is checked with threshold 80 and 120. It can be observed clearly in the graph that the threshold 120 degrades the accuracy in the recognition process. So so the red line here is without the histogram equalization, that is the pre-processing, and we can see that it substantially degrades um, ma the matching accuracy. Then the green line here is for threshold 120, and it clearly shows that this too degrades the accuracy. The line in blue is where threshold is 80 is having better accuracy. The locally adaptive technique for image binarization has the best of accuracy, and it is actually used in the pink line, the pink graph there, which wherein all the steps of the fingerprint matching has been included. It has also been observed that the edge break module removal did not degrade the precision and accuracy much. All steps executed give the best accuracy in the fingerprint matching technique. So if we execute all the stages that has been discussed in the previous slides, then the graph in pink is generated, and it shows that this is the best of all. And if all the steps are executed, the system was around 94% accurate. However, with the increase of noise, the accuracy decreased to 75%. So conclusion and future work. The analysis of the results gives a clear picture that the quality of the input image plays a major role in the accuracy of the fingerprint recognition system. So more the noise in the input image, lesser is accuracy. So we have already seen even after inclusion of all the stages, as in the graph shown in pink, due to noise, the accuracy falls. There are further scopes of increasing the accuracy of the fingerprint recognition system by improving the algorithm of the pre-processing stage, the range thinning, and minutiae detection. Accuracy of the fingerprint recognition system cannot be compromised with, as there are many sensitive applications in which fingerprint recognition is used. Few of such sensitive applications are, voter identification, identification at the borders for entry into different countries, driver's license verification, employee entry to restricted areas, etc. This ever-increasing demand of biometric identification has resulted in researchers to work for the development of optimal and accurate algorithms for fingerprint recognition. So now I want to give a MATLAB demo. So I'll just close it. So first I run this. So this is the UI, and so this program actually calls the various stages which we have discussed. For example, the histogram equalization, the FFT pre-processing, the image binarization, and so on. So for this, first we have to load the image. For example, let me load. So this is the image database which I have tested. So now I'll be loading 101_5, and then I'll apply the histogram equalization. So we can see that it gives a good contrast from the left image. Then I will do a FFT enhancement. So let me put the factor, which is 0.45. It's okay. Then I'll go for the binarization. So now the entire the grayscale is removed, and it is either white or black. Then we get the directional pattern of the ridges. region of interest that is shown in gray, which is the region of interest, and then the thinning. So next is the thinning. So now the ridges have been thinned, then removing of the edge breaks, then remove spikes, then finally we extract the minutiae points. So the color, the points shown in color are the minutiae points, but it as we discussed, it will have we also have to do a post processing, as it will have some false minutiae. So for that we do the real minutiae. So we see that the number of minutiae points here have been reduced in the left than as compared to right. We can save the minutiae points, say 5, file name. Okay, and next is the final stage wherein we do a match. So already from my previous runs I had saved two informations of the fingerprint. So first I will try so 1 and 2 are from two different fingerprints, so let's try and see what happens. So figure 1, open 1, and then it asks for the next input, so I open 2, and say and it says the matching percentage is 30%. And as we have discussed, if the matching percent is less than 80%, then it is not a fingerprint match, which clearly shows that this two fingerprints were from different individuals. Okay, so now let's test another input. So if I take the two input as same, like 1 I have selected for the first, and for the second also if I select 1, then we see that the matching percentage is 100%, which means that the fingerprint belongs to the same person. And okay, so you go back to the presentation. So we have covered everything, and so finally go for the acknowledgement. So I would like to thank Professor Dapeng Olivier Wu for his guidance while doing the pattern recognition course. The concepts learned in this coursework will definitely help us in our future ventures, both in industry as well as in research. Thank you.